Problem number 1. We're supposed to find AD. Well, the angles are the same. These are perpendicular, so these distances should be the same. So AD should be 19. Number 2. We're supposed to find angle EFH. That, of course, is this angle right here, EFH. The distances are the same. They are 90 degrees, so that means the angles will be the same. So this should be 28 degrees, same as the other one. All right, what about this one? Same type of thing. We're supposed to find the measure of angle JKL. Well, we got to be a little bit careful because JKL is the whole angle, so slow down. Since the distances are the same and they are 90 degrees, that means the angles will be the same, 43 and 43. But that means the entire angle, which is what we're being asked for, should be the sum of those two. So that should be 86 degrees. Number 4. Can you conclude that BD is the bisector of angle ABC? Well, if it's going to be the bisector, first thing I'm going to be looking for is I need to know that these distances are perpendicular, 90 degrees. If I do not see 90 degrees, then I can conclude nothing. If it's 90 degrees, then I need to see that either the angles are the same or the distances are the same. So for number 4, I've got the 90 degrees, so far so good. But I don't know anything about the distances. There are no numbers here. So I'm going to say no. And the reason why I'm saying no is because I don't know the lengths, and I also do not know the angles, so I just don't have enough information. On number 5, I'm going to also say no. But this time it's because we are not given 90 degrees. So these distances mean nothing. All right? They're not really the distances to the line unless it's 90 degrees. So that's why. This one, I have the 90 degrees. So far, so good. And these little marks mean that the distances are the same. So I can go ahead and say yes. I'm saying yes because I have perpendicular distances and they are the same. Number 7, find the value of x. I've got perpendicular distances, they are the same. That means these two angles must be equal. So of course I'd set them equal to each other. 4x plus 5 must equal 5x minus 2. Subtract, no, I'm not going to do that. Subtracting 4x from both sides, minus 4x, that's going to give me 5 equals x minus 2. Add 2 to both sides, that's going to give me x equals 7. Okay, so that's the answer to number 7. I've got perpendicular distances, and I'm given that the angles are the same. That means the distances must be the same. So my equation is going to be that 8x minus 9 must equal 4x plus 3. So I'm just going to subtract 4x from both sides. That's going to give me 4x minus 9. 4x minus 9 equals 3, because these are gone. Adding 9 to both sides, that's going to give me 4x equals 12. Dividing both sides by 4 gives me x equals 3. So that's how you do number 8. Number 9, basically the same thing. Perpendicular distances, the angles are the same, so the distances are the same. So that's going to give me 6x minus 17 should equal 3x plus 7. Let's start with the x's. Let's subtract 3x from both sides. That'll give me 3x minus 17 equals 7. Now let's add 17 to both sides. That's going to give me 3x is equal to 24 divided by 3. That's going to give me x equals 8. Alright, so that's how we did number 9. Number 13 is an error analysis problem. We're supposed to describe the error in reasoning, and then we're supposed to say the correct conclusion that we should be able to deduce. These are all angle bisectors, as you can see by the markings. As we learned today, if you have angle bisectors, the point at which they meet is the incenter. So this is the incenter. Okay, now what is the special property of the incenter? All right, the special property of the incenter is that the distances to the sides should be the same. All the distances to the sides should be the same. But here's where we have to be careful. It only counts as the distance to a side if it is perpendicular. This is the key. It's got to be the perpendicular distance. That's what it means when we say the distance to a side. It's understood that we mean the perpendicular distance. Okay? It can't just be any old distance like this. That's not going to be equal. These won't be equal. Only the perpendicular. So the problem with this picture, if you take a closer look at it, this person concluded that HN was going to be congruent to KN. So here's HN and here's KN. And you can tell what they're thinking. This is the incenter, so they were thinking all the distances to the sides would be the same. But the problem is that thing I said about perpendicular. This is not perpendicular. There are no 90 degrees. There's no little box. This is not perpendicular. This doesn't even look close to perpendicular. This is an obtuse angle. This is an acute angle. So these distances will not be congruent because they are not perpendicular. So, if I were going to fix it picture-wise, it'd be something more like this. Trying to draw the perpendicular distance. This distance would be congruent to this distance. These distances would be the same because those are now perpendicular. That's 90 degrees, 90 degrees. Those points are not labeled. They're not marked. So I can't make a nice statement like this. So as far as correcting it, I'm going to say something like, describe the error in reasoning. I'm just going to say this person thought that the distances from the incenter to the sides would be the same. And now I'm just going to write, they forgot that the distances must be perpendicular distances. So this person forgot that the distances to the sides must be perpendicular distances. So that's what they did wrong, and that's how we would correct it. Okay, looking at number 14. Point G is the incenter, find BG. All right, well, this is great. This is the incenter. Again, what is the key special property of incenter? The special property is the distances to the sides will all be the same. So looking back at this picture, the distances to the sides will be the same. that's going to be this distance right here. That's a distance to the side. Notice it's perpendicular like it should be. This distance should be the same, and this distance should be the same. Okay, all those green lines I just drew should be the same. So if I know one of them, I know all of them. But look, we are given one of them. One of them is length 16, so that means they all must be length 16. So BG is another one of these distances, so it should be 16. So that's how you do the number 14. Number 15, point P is the incenter. Find JP. Okay, we are looking for JP up here, and we'll get to that. But first of all, let us emphasize. Once again, if this is the incenter, then all the distances to the sides must be the same, the perpendicular distances. Luckily, these are the perpendicular distances. See the right angles? So that means this distance, and this distance, and this distance should all be the same. So if I find one of them, I found all of them. So we are being asked for JP. We're being asked for this one over here. But I'm not going to find that one. I'm going to find this one down here, PN. And then whatever that is, it should be the same thing. And the way I'm going to find that is by doing a right triangle. That's going to go like this. All right, focus on this right triangle down here. All right, I'm just going to do the Pythagorean theorem. Okay, let me move that off to the side for a second. So I'm just going to do the Pythagorean theorem. We're supposed to find Pn. Pn is going to be this side right here. So that's like my x. 25 is the hypotenuse. That's like right here. 24 is this leg. So I'm going to do my Pythagorean theorem. That's going to go leg squared plus leg squared equals hypotenuse squared. So that's going to give me x squared plus 576 is equal to 625. So if we just subtract 576 from both sides, that's going to give me x squared equals 49. If I then take the square root of both sides, that's going to, of course, give me x equals 7. So that means this is 7 for where Pn is, but again, because it's the incenter, all three of these lengths should be the same. So if this one is 7, that means this one is 7 also. Okay, so that's why the answer is 7. Okay. Looking at number 16, we're finding the value of x. I feel another Pythagorean theorem coming on. Let's see what happens. Here's how it breaks down. Again, the key thing about incenter, if this is the incenter, what is the special property of the incenter? For incenter, all the distances to the sides should be the same. So that means in this case, these three red lines should all be the same. That means if one of them is 4x, then all of them should be 4x. So that means this one up here should also be 4x. So I'm going to go ahead and do another Pythagorean theorem. So look at this triangle right here. Okay? that goes like this. Okay, that was not very well drawn, but it's difficult to write with this weird pen. So I'm going to take this triangle and move it over so we can work on it. Okay. So again, what I've got is this side over here is 4x. And this leg up here is 48. And the hypotenuse right here is 52. So I'm just going to use the Pythagorean Theorem to find x. So that's going to look like this. Leg squared plus leg squared equals hypotenuse squared. So 4x squared plus 48 squared is equal to 52 squared. So 4x squared, that's like 4x times 4x. That's going to be 16x squared. All right, 48 squared is 2,304. So 2,304, and 52 squared, 2,704. So 2,704. So subtracting 2,304 from both sides, that's going to give me x squared is equal to 400. All right, and then we would divide both sides by 16. So that's going to give me x squared equals 25. Then I would take the square root of both sides, and that's going to give me x equals 5. Okay, so that's how you would find the value of x. All right, number 17. This is basically the same exact thing. This time I'm going to look at this triangle over here. Fail. You know what? Good enough. I'm going to look at this triangle right here. So again, because this is the incenter, these blue lines here, okay, these distances to the sides should all be the same. So if this distance is 3x, then this distance right here should also be 3x. All these blue lines should be the same for the incenter. So looking at this triangle over here, here's my 3x, okay, my 90-degree angle. This is 45, and 51 is my hypotenuse. So I'm really doing the exact same thing I just did on the other problem. So I'm doing leg squared, so 3x squared plus 45 squared is equal to 51 squared. In fact, I'm going to work all this out right now off camera, and then I'll just show the answer. All right, look over the solution for a few seconds. If you need to pause the video in order to study it, you go ahead and pause the video. But the answer is 8, and here's why. It's the exact same as the last problem, so I'm going to move on. Okay, for number 18. The monument, you're building a monument in a triangular park. You want the monument to be the same distance from each edge. That's key. Each edge of the park. Okay, now look. These are two things that students get confused sometimes. We've dealt with circumcenter, and now we've dealt with incenter. their properties are similar but different. For circumcenter, the distances to the vertices should be the same. So all of these distances to the corners will be equal. For the incenter, the distances to the sides should be the same. So anytime we need a spot that's equidistant from the sides, we're going to do the incenter. Anytime we need a spot that is equidistant from the corners, the vertices, then I will use the circumcenter. So keep that in your mind. Okay, so use the figure with incenter G to determine how far from point D you should build the monument. So understand that the reason why they're doing incenter is because we want the distances to be the same from each edge. That's a side. So if we do the incenter, the distances to the sides will be the same. So how far from point D? So we're just talking about the distance from G to D. We're talking about this right here, which I'm going to call X. And again, this is just going to be straight Pythagorean theorem. A lot of Pythagorean theorem going on. So focus on this 90-degree triangle. Okay, so here's my 90-degree triangle. All right, I'm going to pull it off to the side so we can work with it better. So what I have, looking at this triangle, I've got 120 feet right here, 125 feet, that's my hypotenuse, and X is this side of the triangle, because that's what we're trying to find, the distance from point D. Okay, and from this is the monument to point D, so that's X. So it's just the Pythagorean theorem. You really probably don't need any more help on this. In fact, I'm going to do all the work off camera again. Alright, so here's all the work of me doing the Pythagorean theorem. From leg squared plus leg squared equals hypotenuse squared. Worked it all out. I got x equals 35, so 35 feet. That's how far away the monument should be. So that is how you do that problem. Number 18.